Today we discuss the next questions regarding data science. So question is that explain practical access superstep. Let us first consider an example of networks routing. Python uses a library called networks for networks routing. To use networks X library, first install the library on your machine. Means first you have to install the networks X library on your machine by using following command on your command prompt. Pip install network X. Network X is a Python package for the creation, manipulation, and study of the structure, dynamics, and functions of complex networks. Means you have to first install in a Python network X library on your Python application by using uh, command like pip install network X. Network X provides tools for the study of the structure and dynamics of social, biological, and infrastructure networks. A standard programming interface and graph implementation that is suitable for many applications. A rapid development environment for collaborative multidisciplinary projects. Okay, an interface to existing numerical algorithms and code written in C, C++, and Fortran, and the ability to painlessly work with large non-standard datasets. With Network X, you can load and store networks in standard and non-standard data formats, generate many types of random and classic networks, analyze network structure, build network models, design new networks. Network algorithm, draw networks, and much more. Here is graph theory for network analysis. In the following graph theory, a graph has a finite set of vertices, that is V, and connected to elements E, edges. Each vertex, that is vertices V, connected to two distinct distinctions or nodes is called as a link or an edge. Okay, so vertices connected with each other and there is a link, and that link is called as an edge. Consider the graph of bike paths below. Sets KL, FG, GH, EHL, AB, and CF are the examples of the edges. The total number of edges for each node is the degree of that node. Means if there is any node, each how many edges are connected to that particular node is called as the degree of that particular node. In the graph above, M has a degree of 2, that is MH. Means M is a node and M has connected with vertex H. So this is an edge, that is MH, and ML. So there is a degree of node is a 2, while B has a degree 1 because B vertices has only one node is connected, that is A. So there is only one edge, so degree of that node is a 1. Degree of that graph is equal to number of links involving I. Here is the formula, that is summation of n number of degrees. J of is equal to 1, G of ij. That is connections through use of multiple edges are called path. Okay, when a number of edges are connected between various nodes and making a path, like F, H, M, L, H, G, H, J, G, I is an example of a path. Here is like F, G, I, K, L, M, H is called as a path. A simple path is when path does not repeat a node, formally known as a Eulerian path. That is, in example, I, G, J, H, F. Here is example I, G, J, H and F. Here is an path, so there is no repeat of any node. So it is called as an Eulerian path. Is an example of simple path. The shortest simple path is called as classic geodesic between I and J. That is uh, I, G and J. I, G and J is called as a shortest simple path, or IKJ is also called as a shortest simple path. Finally, a cycle is when path starts and end points are the same, like HMLH. Here is HMLH. Is a starting point starts from H and ends with H. It is called as a cycle. Not all networks in a graph system are interconnected. This disconnection is when components are formed. As shown in the graph below, a component is formed only when every node has a path other nodes. Here is the example of that. Second question is that explain transform superstep. The transform superstep allows us to take data from data vault and answer the questions raised by the investigation. Means when data is taking from data vault and investigator means who asks the questions and investigation something from the data, who raise questions, that time it takes data and transform that data to the investigation investigator. It takes standard data science techniques and methods to attain insights and knowledge about the data that then can be transferred into actionable decisions. This result can be explained to non-data scientists. The transform superstep uses the data vault from the process step as its source data. It takes data from the source data or process superstep. There is some model uh, for the explanation of the transform superstep. First model is a Sun model. Sun model technique is used by data scientists to perform consistent dimension consolidations. It allows us to explain data relations or data relationship with the business without going to technical details. Here is a subtype of Sun model, that is person to time Sun model. Person to time Sun model explains the relationship between person and time categories in the data vault. The Sun model is constructed to show all the characteristics from the two data vaults hub categories. It explains how you will create two dimensions and a fact why via the transform step from below figure. Here is a figure person to time Sun model. Here is a person and here is a time. In person to time Sun model, from there is a two fact, there is a two dimensions and a fact. Okay, two dimensions which there are person is one dimension and time is another dimension. In a person dimensions, like person's birth date, person's last name, person's first name, person's ID. These are some dimensions. Where is in a time zone, local time, UTC time, and time ID is the another dimension. Means there are basically there are two dimensions, persons and time, and they are categorized into that. So this is called as person to time sun model. Next is person to object sun model. Another sub type is a person models, two type, person to time sun model and person to object sun model. In a person to object sun model explains the relationship between person and object categories in the data vault. The Sun model is constructed to show all the characteristics from the two data vault hub categories. It explains how it will create two dimensions and fact via the transform step from figure. Here is a here is a two dimensions persons and object. So in a persons again, birth date, last name, first name, person ID, and in an object there is a common name, longitude, and latitude. This is the person to object sun model. Next, person to location sun model. In a person to location sun model explains the relationship between persons and location categories in the data world. The sun model is considered to show all the characteristics from the two data vault hub categories. It explains how you create two dimensions and a fact via the transform superstep from the figure. Like that, here is again two dimensions, that is person and location. Again person dimension is has again categories like birth date, last name, first name, person ID, whereas in location there is a dimensions time zone, longitude, latitude, location ID. These are sub dimensions. Next category is person to event sun model. Person to event sun model explain the relationship between the person and the event categories in the data vault. Here is again person dimension has same birth date, last name, first name, person ID, and event category has event born, event ID 0. So sun model to transform step, you must build three items, that is dimension person, dimension time, and last is a fact. So next question is define data warehouse and explain how to build data warehouse. In computing, a data warehouse, also known as an enterprise data warehouse, is system used for reporting and data analysis and is considered a core component of a business intelligence. A data warehouse is a relational database that is designed for query and analysis rather than transactions processing. It includes historical data derived from transactional data from single and multiple sources. A data warehouse provides integrated, enterprise-wide historical data and focuses on providing support for decision making for data modeling analysis. A data warehouse is a group of data specific to the entire organization, not only to a particular group of users. It is not used for daily operations and transactions processing, but used for making decisions. A data warehouse can be viewed as a data system with the following attributes. It is a database designed for investigative tasks using data from various applications. It supports a relatively small number of clients with relatively long interactions. It includes current and historical data to provide historical perspective of information. Its uses is read intensive. It contains a few large tables. Data warehouse is a subject oriented, integrated, and time variant store in a formation in support of management decision. This is the data warehouse definition. It is a subject oriented, it is an integrated, and it is a time variant. The steps to building a successful data warehouse, there are multiple steps. Whenever you have to build a data warehouse, a data warehouse will help you to build accurate forecasting models and identifying impactful trends. So first step is defining business requirements. Since a data warehouse encompasses all areas of your business, it's vital that every department is involved with the design process. Setting up physical environments, your data warehouse typically have three environments which mimics software development best practice. The three environments are development, testing, and production. Introducing data modeling. Data modeling is the blueprint from which the data warehouse is built. It can help you visualize data relationships and establishing security process compliance. This is known as the most complex phase of the data warehouse. Next is choosing your ETL solution. ETL stands for extract, transform, and load. So ETL means extract, transform, and load, and it represents the collection and processing of data from various sources into one central data store where it can be later analyzed. Next step is online analytical processing, that is OLAP Cube. And OLAP Cube helps you to analyze the data in your data warehouse or data mart. Creating a front end. This stage refers to front end visualization where users can understand and apply the results of data queries. Another area of importance is the complexity of the reporting tools. Next step, optimizing queries. The more data returned from a query, the more resources the databases and needs to expand to process and store this data. This stage is very specific to each organization's needs. Next step, rolling out the end product. The hard work has now been done and you are close to getting value from your shiny new data warehouse. Ultimately, a successfully implemented data warehouse will deliver value at every level of your organization. Here are some short notes. First short note is hypothesis testing. So hypothesis testing is not precisely an algorithm, but it is a must known for any data scientists. You cannot progress until you have thoroughly mastered this technique. Hypothesis testing is the process by which statistical tests are used to check if a hypothesis is true by using data. Means hypothesis testing is an assumption. Whenever you have to research any thing, you have must define your hypothesis, and hypothesis testing is a statistical tool. Hypothesis testing is the process by which tests are used to check if hypothesis is true by using data. Based on hypothetical testing, data scientists chose to accept or reject the hypothesis. When hypothesis is true or accepted, means your final outcome is assumed, or if it can be rejected, it means that you have not got your final output. When an event occurs, it can be trend or happen by chance to check whether the event is an important occurrence or just happens? Hypothesis testing is a necessary. There are many tests for hypothesis testing, but the some tests are like Z test, chi-square test, etc. Next short note is a cross validation test. Cross validation test is a model validation technique for evaluating how the results of a statistical analysis will generalize to an independent dataset. It is mostly used in a settings where the goal is the prediction. Knowing how to calculate a test such as this enable you to validate the application of your model on real world, that is independent datasets. Here are one example is given in a Python, that is to check the cross validation test. Uh, Here are import some numpy files and check entered cross validation test here. Next short note is overfitting and underfitting. Overfitting and underfitting, these are the major problem faced by the data scientists when they retrieve the data insights from the training data sets which they are using. They refer to deficiencies that the model's performance might suffer from. Overfitting occurs when the model or the algorithm fits the data too well. When a model gets trained with so much of data, means excess of data, it starts learning from the noise and inaccurate data entries in our data sets. But the problem then occurred is the model will not be able to categorize. Means access a noisy or inaccurate data, and whenever you have to retrieve that data, it has a much amount of data or excess data. But at the time of problem occurred when model is not able to categorize that data, the data is correct or not, and this happens because of too much of the details and noise. Whereas in underfitting occurs when the model or the algorithm cannot capture the underlying trends of the data. Initially, underfitting occurs when the data model or the algorithm does not fit the data well enough. Means there is not enough data to analyze. It is often a result of excessively simple model. It destroys the accuracy of our model. Here is an example of underfitting, overfitting, and just right data. Polynomial features here are the polynomial formula is the following: a1x of b1 or a2x plus b2, that is the a1 a2x square plus a1 b2 plus a2 b1 x plus b1 b2. This is the formula that is used for overcoming overfitting and underfitting issue. The polynomial feature extraction can chain of polynomial formulas to create a hyperplane that will such divide any datasets into the correct clustering groups. The higher the polynomial complexity, the more precise result that can be achieved. Common data fitting issues are these: higher order polynomial formulations are, however, more prone to overfitting, while lower order formulas are more like to underfit. It is a delicate balance between two extremes that support good data science. Here is the end of today's lecture.